Positive displacement compressors work by trapping a certain amount of gas and forcing it into a smaller volume. A common type of positive displacement compressor is a reciprocating compressor. This simplified illustration shows two main parts of a typical reciprocating compressor: a cylinder and a piston. In this compressor, gas enters the cylinder and is trapped inside the cylinder. The gas is then forced into a smaller space by the action of a piston. Forcing the gas into a smaller space increases the pressure of the gas. The compressed gas is then discharged. Centrifugal compressors work differently. A centrifugal compressor uses a device called an impeller to spin the gas around, which accelerates or increases the speed of the gas flow. The acceleration gives the gas energy. As the gas stream flows out of an impeller, it spreads out and slows down. As the gas slows down, its energy is converted into pressure. Although positive displacement and centrifugal compressors operate differently, they share certain characteristics. For example, all compressors are rated according to discharge pressure and flow rate. Discharge pressure is usually expressed in terms of pounds per square inch, or PSI, and flow rate is often expressed in units of cubic feet per minute, or CFM. All compressors also require some form of drive mechanism. Electric motors, such as this one, are commonly used to drive compressors. Other drive mechanisms you may encounter include gasoline engines and steam or gas turbines. Compressors are used in many different types of compressed gas systems, and a particular facility may have several compressed gas systems. We can use this simplified illustration to identify the basic components of a typical compressed air system. You may also hear a compressed air system referred to as a pneumatic system. The system includes a reciprocating compressor with 2 cylinders and 2 pistons, an intercooler, an aftercooler, a demister, a safety valve, and a receiver. The compressor is a multi-stage reciprocating compressor. A multi-stage reciprocating compressor contains 2 or more cylinders connected so that the discharge of one cylinder is directed into the inlet of another cylinder. The compressor in this example takes in air at atmospheric pressure and increases its pressure in 2 stages. In the first stage, the compressor increases the pressure of the air to approximately 25 psi. As the air is compressed, its temperature increases. The air that leaves the first stage of the compressor is routed to the intercooler. The intercooler is a shell and tube heat exchanger. As the air passes through the tubes in the intercooler, it is cooled by water flowing around the tubes. The cooled air from the intercooler is routed to the second stage of the compressor. In the second stage of this compressor, the air's pressure is increased to approximately 120 psi. From the second stage, the compressed air is sent to the aftercooler, which is another shell and tube heat exchanger. As the compressed air passes through the tubes in the aftercooler, it is cooled by water flowing around the tubes. During the cooling process, any water vapor that is in the air condenses. As a result, there may be moisture in the compressed air. So, the compressed air is sent from the aftercooler to the demister, which removes moisture from the compressed air. Moisture is removed to prevent it from damaging equipment that uses compressed air. Inside the demister, the compressed air is swirled around inside a cylinder. The swirling action causes the heavier moisture to separate from the lighter air and collect in the bottom of the cylinder. The moisture is then drained from the system. The dry compressed air is routed to other components in the system. The function of the safety valve is to protect the system from excessive pressure. If too much pressure builds up, the safety valve will open to relieve the pressure. The receiver is a tank that's used to store dry compressed air. From the receiver, the compressed air is sent through piping to other systems at 120 psi.